Guys, we are continuing from where we stopped in our previous video. We are still on wave. So we are still solving problems under wave. So let's take out another question here. So in this question now, we have to calculate the frequency. That is, what is the frequency? The frequency of a radio radio wave of wavelength 150 meter. If the velocity of radio waves in free space is 3 times 10 raised to power 8 meters per second. Like I said in our previous lesson, once you are given a question like this, the first thing is to understand the given question. After you understand the given question, now go to the solution. The first thing you have to do here is to write out the given parameter. Here now, the wavelength is given as 150 meter. At the same time, we're given the velocity as 3 times 10 raised to power 8 meter per second. The unknown value here happens to be the frequency which we are looking for. For us to stop for frequency here, with the aid of this parameter that has been written now, you can now, with this now, we've already know the formula that leads us to the solution of this question. With this, since we know that the unknown value there is frequency, we are still making use of this formula V equals F lambda, where V is the velocity equals frequency multiplied by what? Wavelength. So in this case, we are making use of this formula. We can put the whole data into the formula. We are going to have it as 3 times 10 raised to power 8 equals F multiplied by 150. From there, we have 3 times 10 raised to power 8 equals 150 F. For us to add the value of our frequency, we need to make F, and this frequency, the subject of the formula. We do that by dividing both sides. By the coefficient of F, which is 3 times 10 raised to power 8 equals 150 divided by 150 divided by 150. 150 here out, cancel out the other 150 numerator side. Then now left with F equals 3 times 10 raised to power 8 all over 150. So we should now go to the value of Since our help is now equals to 3 times 10 raised to power 8 all over 150. You know, the numerator side, we have it in standard form. You can as well decide to change the denominator side to into standard form as well by saying F equals 3 times 10 raised to power 8 all over 1.5 times 10 raised to power 2. From there, you can now have it as F equals 3 all over 1.5 multiplying by 10 raised to the power 8 minus 2, according to the law of indices here. The two exponential, when we are dividing, you have to subtract the power of the two exponential. Now that F equals 1.5 goes in 3 is going to be 2 multiplied by 10 raised to the power 8 minus 2. That's going to be 6. That shows our frequency is 2 times 10 raised to the power 6 half. Mind you, you must remember to put the unit. Bell frequency in half. That's the solution to this question. Let's see, maybe we can still solve for that. Example 3. This example has to do with wave diagram. As you can see, the wave diagram starts from node D and ends at node E. In this given question, we are told that the diagram above represents part of the wave motion in air. If the wave travels with a speed of 300 meters per second, that will calculate the frequency of the wave. Solution. The first thing we do, we write down the given parameters to be 300 meters per second. And if you look at the graph, you have been given a specific distance. That is the wave distance, which you can as well call wavelength as 3 meters. And if you look at it again, we're given another distance, that is distance between successive crests. If you look at it, the distance between this crest to this crest is given as wavelength. From this crest to the other crest is given as wavelength. From this to this is given as wavelength over 2, which is also telling us same thing as the wavelength we have been given as 3 meters. In this case now, we have it's as if we are having 2 wavelengths. So in this case, you have to relate the 2 wavelengths together. How can we relate them? Is by equating the 2 wavelengths to each other. Equating the 2 wavelengths. When we equate the 2 wavelengths, it's going to be wavelength plus wavelength plus wavelength over 2 equals 3. Wavelength plus wavelength will give us 2 wavelength plus wavelength over 2 equals 3. From there now, you can start to find the LCM by putting 1 as the denominator of this. When we look for the LCM, the LCM is going to be 2. 1 goes in 2. That's 2. 2 times 2 is going to be 4 wavelengths. Plus 2 goes in 2. 1. 1 times wavelength is going to be wavelength. Equals to 3. 4 wavelength plus wavelength will give us 5 wavelength all over 2 equals 3. We now cross multiply for us to know the value of our wavelength. So when we cross multiply, it's going to be 2 times 3 equals 5 wavelength times 1. 2 times 3 here will give us 6 equals 5 wavelength. For us to know the value of our wavelength, you have to divide both sides by the coefficient of wavelength. And the coefficient of wavelength in this equation on the board is 5. That shows we are dividing both sides by 5. We will be divided by 5, divided by 5. When 5 goes here, I'm going to be left with wavelength equals 6 all over 5. And 5 goes in 6, goes once, remainder 1. That one, we added 0 to that one in terms of decimal. 5 goes in 10, that's going to be 2. That is how we arrive at our wavelength as 1.2 meter. We measure wavelength in what? In meter. That is why it's 1.2 meter. We will solve for our wavelength, but we will not solve for the real. We will not solve the real value we have to find. But we will not solve for the real value we have to find, which is the frequency. Once you now get the frequency, in as much you have been given the velocity, and now we've known the real value of our wavelength, 1.2. Now make use of the formula V equals F wavelength, that is velocity, equals frequency times wavelength. From there now, we compute the formula into the data into the formula. We are going to have our velocity, which is given as 300, equals the unknown frequency times the wavelength, which is 1.2. From there, now 300 equals 1.2 Earth. Divide both sides by the coefficient of Earth. That means we are dividing both sides by 1.2. F will now be equals to 300 divided by 1.2. 300 divided by 1.2. F equals to 300 over 1.2. And 1.2 divided by 300 will give us F equals to 250 Hertz. That's going to be the final answer. This is example 3 now. I wanted to deal with the equation of progressive transverse wave. The question goes thus: y equals 2 sine wavelength, 2 sine 2 wavelength, open bracket, t all over 0.02 minus x all over 40 close bracket, where x and y are in centimeter and t in circles. You have to determine one. Determine one. The amplitude Number 2, the wavelength. 3, the frequency. And 4, the speed. The speed of propagation. The speed of propagation of the wave. Of the wave. Solution. Body, which I call equation of transverse wave. Students normally have problem on this very question because they believe whenever they see it like this, they will not be able to solve it. That's the first belief they have. How will I get it? I have problem with this wave equation, and it's not as that difficult to solve. The only thing you have to do if you are given an equation like this, you go for the general wave equations that correlate with the given equation. Unlike this now, but the general equation that correlates with this is y equals to a sine 2 lambda, a sine 2 lambda, open bracket, t all over t minus x all over wavelength, bracket close. This is the general equation that suits the given question. The only thing you have to do is to do comparisons between the two equations. The two equations as I want you to do as the question is y equals 2 lambda, open bracket, t all over 0.2 minus x all over 40. Equation. This is the general equation. I wanted to do comparison between the two. The general equation is y equals a sine 2 lambda 2 wavelength, bracket open, t all over t minus x all over wavelength, all in bracket. Comparing the two equations. Comparing the two equations here, you can see your y is 1, at the same time y is 1, a is 2, sine is sine, 2 is 2 there, wavelength is wavelength, t here is 0.02, wavelength here is 40 here. With this now, I have to determine the amplitude. Amplitude is being represented in the general equation as with a what? Letter A. Comparing the two equations here, you can simply say that amplitude is equals to 2 centimeters. Because you have been told that here x and y are in centimeters. After that, you have to find the wavelength. The wavelength. The wavelength. You have to find the wavelength. You solve for equation 1 for the amplitude. Compare the two. The amplitude is 2 centimeter. In terms of wavelength now, if you don't know your frequency, there's no how you can come across the value for your wavelength. The first thing to do, having gotten our amplitude to be 2 centimeter, the next question here is that you have to find the wavelength. You have to determine the wavelength. The wavelength is just as simple as comparing the two equations again. When you compare the two, where we're having wavelength here, we have 40 in the given equation. In general equation here, we have wavelength in place of 40. In that case, our wavelength is also equals to 40 centimeter. The next field there, we have to find what to determine the frequency. Once we determine our frequency, when we look at the comparisons, where we have t here, we have 0.02. That is, t is equals to 0.02. And there is a formula that says that F equals to 1 over T. F equals to 1 over T for frequency. If we are to, since there's a formula that says F equals to 1 over T, if we should substitute for T in this formula, we are going to have our F to be equals to 1 over 0.02. 1 over 0.02, F will be equals to 1 divided by 0.02 to give us 50 as, which happens to be the unit of our frequency. The question number 3. For us to now find the speed of the propagation, V, which is unknown, and in the comparisons here, we don't have anything like V in both the given equation and the general equation. In that case, we have to derive the value for our velocity with the parameters that we got in earlier by using the formula V equals F wavelength, that is frequency multiplied by wavelength. So our V will now equals to what is gotten as our frequency, which is 50, multiplied by what we got in as our wavelength, which is 40. 50 times 40, 4 will give us 20. The addition of the two zeros will give us what? 2,000 meter per second. That's the final answer with the equation. The wavelength, the frequency, and the speed of propagation of the wave. And that's the end of the question. In our next class, we are going to continue with the solving of problems under wave based on light wave. Because what we have been doing earlier are mechanical wave. Now next time we are going to move into problems on light wave. Light wave. That's problems. So it's going to be problems on light waves. That's going to be our next calculation on the between frequency, wavelength, and velocity. The formula that relates the three terms together is V equals F lambda. This velocity equals to frequency multiplied by wavelength, which means